In this video, I will discuss the probability for winning the Mega Millions jackpot and the probability for winning each of the smaller prizes, as well as the mathematics behind these calculations. I'll begin with the rules of the Mega Millions lottery, about the 1-minute mark of this video, and then move on to the mathematics behind calculating the probability of winning the big jackpot. This will happen in about 2 minutes, 30 seconds. And then I'll go through the process of calculating the probability of winning each of the smaller prizes in the Mega Millions jackpot after about 11 minutes and 25 seconds. And finally, at the end of the video, after about 35 minutes, we'll take a look at a summary of the results. In the description below, you can find links to all of the different parts of the video where the probabilities for each individual prize are calculated and the mathematics behind them are described. The Mega Millions jackpot, the Mega Millions lottery, contains 2 separate containers of balls. Each ball contains a number. The first container of numbers has numbers from 1 to 70. The second container, which contains what's known as the mega ball, has values from 1 to 25. In a Mega Millions lottery drawing, from the first container, 5 numbers are drawn. 5 numbers between 1 and 70 are drawn. When these numbers are selected, they are not returned to the container. So for example, if a value of 3 was drawn for the first number, you will not see 3 drawn again in those first 5 values. It's not put back into the container. Then, from the second container, the mega ball container, 1 number is drawn. To win the jackpot, you must match all of the first 5 numbers in addition to the mega ball that comes from the second container. This jackpot is not always the same. The jackpot will begin at $40 million, and if no one wins, it increases. Each time there is a Mega Millions drawing and no one wins, the jackpot increases. Let's talk about the probability of winning that jackpot. So, if you buy a single ticket, what is the probability of your winning the jackpot? Well, to win the jackpot, you must match the first 5 numbers and match the mega ball. Therefore, your probability of winning the jackpot is the probability of matching those first 5 numbers times the probability of matching the mega ball. Anytime you're trying to find the probability of 2 separate events together, the total probability is the probability of the first event occurring times the probability of the second event. In this case, it's again the probability of matching the first 5 numbers times the probability of matching the mega ball. So we're going to have to calculate both of these probabilities. So first, let's calculate the probability of matching the first 5 numbers drawn. All 5 must be matched. However, it's important to know that the order in which those first 5 numbers are drawn does not matter. For example, if your numbers are 1, 2, 3, 4, 5 on your ticket, and the numbers drawn are in the order of 5, 4, 3, 2, 1, you have still matched all 5 numbers. When calculating probability, a selection of items from a collection where order is not important is called a combination. In mathematics, there is a formula for calculating a combination, and it's written like this. This would be read aloud: n choose 4 equals n factorial over r factorial times n minus r factorial. This may look complicated, but evaluating combinations really only requires multiplication and division, though sometimes those operations are occurring on fairly large numbers. First, n is the number of items in the set of possible values. In this case, that would be 70, because those first 5 numbers are drawn from values that could be anything from 1 through 70. 70 possible values is the value of n. R is the number of items that will be selected. We are selecting 5 of the numbers from a set of 70. So, substituting a 70 for n and a 5 for r in the combination formula is equal to 70 choose 5, which is 70 factorial over 5 factorial times 70 minus 5 factorial. Now, a factorial, just as a little review of factorial, for example, 5 factorial will be equal to 5 times 4 times 3 times 2 times 1. Anytime you're taking the factorial of a number, you're multiplying that number times a factor of every number lower than it. 70 factorial over 5 factorial times 70 minus 5 factorial can be simplified like this. What I've done here is I've taken 70 factorial and instead of writing it out the whole way, I've just taken 70 times 69 times 68 times 67 times 66 times, and instead of going the whole way down to 1, I've written this as I've stopped at 65 factorial, which represents 65 times every number smaller than it. And the reason that I've done that is because look in the denominator. In the denominator is 70 minus 5 factorial, and 70 minus 5 is, of course, 65 factorial. And that leaves you with a fraction that has a factor of 65 factorial in the numerator and 65 factorial in the denominator. Those can cancel out. Those are going to divide away to be 1. Even though 65 factorial is a very, 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 very large number, it's going to be identical in the numerator and denominator. They'll be able to cancel out. So all that you're left with after that cancellation in the numerator is 70 times 69 times 68 times 67 times 66. And in the denominator, the 5 factorial is 5 times 4 times 3 times 2 times 1. Doing that multiplication, and I needed a calculator to do this calculation, but the product in the numerator is 1,452,361,680 over 120. This divides to be 12,103,014. This means that the probability of matching the first 5 numbers is 1 in 12,103,014. There are 12,103,014 exactly that many possible ways, that many combinations, if you will, that 5 numbers can be drawn from a set of 70. Because there are that many possible combinations, the probability of matching the 5 numbers that you pick on your ticket exactly is 1 in 12,103,014. Once you know the probability of matching the first 5 numbers, you then multiply that by the probability of matching the megaball. Finding the probability of matching the megaball is much simpler than finding the probability of matching all of the first 5 numbers. The megaball is simply one number drawn from a set of 25. The probability is simply 1 in 25. We could apply the combination formula to this, drawing one value from a possible set of 25 would be written as a combination 25 choose 1, 25 factorial over the r, 1 factorial times n minus r factorial, 25 minus 1 factorial, which could be simplified in a similar way that I simplified the combination when calculating the probability of the first 5 numbers. In this case, it will be a factor of 24 factorial that cancels out, and I'm left with 25 possible ways in which the megaball can be drawn. And that should make perfect sense. You're drawing one number from a set of 25. The megaball could be one of any 25 numbers. The probability of matching the megaball is 1 in 25. Now, the probability of winning the entire jackpot. The probability is the probability of matching the first 5 numbers and the probability of matching the mega ball. Remember, when you're trying to find the probability of 2 separate events happening, you multiply the 2 probabilities. In this case, the probability of matching the first 5 numbers and the probability of matching the mega ball. We now know those 2 probabilities. Probability for matching the first 5 numbers is up here. Probability of matching the mega ball, 1 in 25. Let's multiply those. This is a pretty large multiplication. 1 over 12.1 million times 1 over 25 is equal to exactly 1 over 302,575,350. This is the probability of winning the Mega Millions jackpot. 1 in over 302 million. As a percentage, this would be 0.000000033%. It's a long shot. In actuality, it's 1 in 302,575,350 to win the Mega Millions jackpot. Next, I will discuss the probability of winning the other smaller Mega Millions prizes. In addition to the jackpot, there are 8 other ways to win a prize in the Mega Millions drawing. As you would expect, the more numbers you match, the bigger the prize. Matching 5 numbers without the mega ball wins you $1 million. The prize amounts go down from there. The smallest prize, awarded for matching only the mega ball, is $2. For the remainder of this video, I will describe the process to find the probability of winning each of the smaller prizes. Each of these problems involves using the combination formula that we already discussed in some way. Let's begin. As I discuss the probability for winning the other smaller prizes, I will refer to some information that was already presented. 2 very important facts that will be used when computing the probability of winning the smaller prizes are the total number of ways that the first 5 numbers can be drawn, the total number of combinations those first 5 numbers out of 70 can be drawn is 12,103,014. That's how many ways there are to draw the first 5 numbers out of 70. Additionally, the number of combinations, the number of ways the mega ball can be drawn. That's simpler. There's 25 ways the mega ball can be drawn. These 2 facts will be very important as I compute the other probabilities. Now, if you don't win the jackpot in the Mega Millions drawing, the next highest prize is awarded for matching the first 5 numbers without the mega ball. This will win you $1 million. To find the probability of winning this prize, it is fairly easy based on the work that we already did. What we'll have to figure out is the probability of matching those first 5 numbers, and we'll multiply that by the probability of not matching the mega ball. This probability will be the probability of matching the first 5 numbers, which we already determined to be 1 in 12,103,014, times the probability of not matching the mega ball. Well, the probability of matching the mega ball would be 1 in 25, 1 out of the 25 possible ways the mega ball can be drawn. The probability of not matching it would be the other 24 ways. You have a 24 in 25 chance of not matching the mega ball. So the probability, the total probability to match 5 numbers without the mega ball is 1 over 12.1 million times 24 over 25. This product is approximately, at least to the nearest hundredth, 1 in 12,607,306.25. This is your probability of matching 5 numbers without the mega ball and winning $1 million. As a percent, this is again very small, 0.00000079% is your percent chance to match 5 numbers without the mega ball. The next biggest prize can be won by matching 4 of the first 5 numbers drawn with the mega ball. This would earn you $10,000. To determine the chances of winning this prize, you must compute the probability of matching exactly 4 out of those first 5 numbers and multiply that by the probability of matching the mega ball. What we're doing here, what we have to figure out is how many ways out of the 12,103,014 ways that those first numbers can be drawn, how many ways result in 4 correct numbers and 1 incorrect number. And that will be multiplied by the probability of matching the mega ball, which is 1 in 25. To determine how many ways there are to draw only 4 matching numbers out of the winning 5, where order again does not matter, we will use a combination. We'll use the combination formula. This would be written as 5 choose 4. This is called a combination. There are 5 winning numbers. We need to choose 4 of them. Now, we will multiply that by the number of ways the remaining number is not a winning number. Of the 70 total numbers that are drawn first, 5 are winners and 65 are losers. How many ways can you draw 1 losing number from the remaining 65? Well, there are 65 ways. Writing this as a combination will be 65 choose 1. I will now apply the combination formula, which was discussed earlier. 5 choose 4 is 5 factorial over 4 factorial times 5 minus 4 factorial, and 65 choose 1 is 65 factorial over 1 factorial times 65 minus 1 factorial. Simplifying these gives 5 for the first fraction, and 65 factorial over 1 factorial times 65 minus 1 factorial simplifies to 65. 5 times 65 has a product of 325. This means that the number of ways there are to match 4 of the first 5 numbers, the number of ways those can be drawn out of a possible 12 million is 325. 325 ways out of the over 12.1 million ways those first 5 numbers can be drawn result in matching 4 out of 5. This means multiplying 325 times 1, multiplying 325 times 1 and 12,103,014 times 25, and simplifying, there is about a 1 in 931,001.08 probability of matching the first 4 numbers with the mega ball. As a percent, this means that you have a percent chance of winning this prize as 0.000107% chance of matching 4 numbers with the mega ball and winning $10,000. Calculating the probability of matching 4 numbers without the mega ball, the next highest Mega Millions prize, $500, is fairly easy because we just did most of the work. What we have to compute here is the probability of matching 4 of the first 5 numbers, which we just found, and multiply that by the probability of not matching the mega ball. Now we just found that the probability of matching exactly 4 out of the first 5 numbers is 325 out of the 12,103,014 possible ways there are to draw those first 5 numbers. We'll multiply that by the probability of not matching the mega ball. Well, there's 25 numbers that the mega ball is drawn from. 1 out of those 25 matches the mega ball. 24 out of 25 does not. When I take this product and reduce it so that there is a 1 in the numerator, I get 1 over 38,791.71. The probability of matching 4 numbers without the megaball is 1 in 38,791.71, at least to the nearest hundredth. As a percent, this is 0.002578%, your percent chance of winning the $500 prize from matching 4 numbers without the megaball. The next highest prize, $200, is won by matching 3 numbers with the megaball. Similar to what we've done when calculating the probability of winning the other prizes, we're going to do a multiplication. First, we'll multiply the probability of matching exactly 3 of the first 5 numbers times the probability of matching the megaball. What's going on here is we have to figure out when we are determining the probability of matching 3 of the first 5 numbers, we're determining how many ways, how many combinations there are when drawing the first 5 numbers, how many of those combinations result in matching exactly 3 out of the first 5 out of the 12.1 million ways there are to draw those first 5 numbers. We figured out there were 12 million ways to draw those first 5 numbers when we were computing the probability of winning the jackpot. And now we just need to determine the number of ways there are to match 3 out of 5, and then take that out of the 12 million possible ways there are to draw those first 5 numbers. The probability of matching the megaball, very easy. There's 25 megaball numbers. One of them matches. The probability of matching the megaball is 1 in 25. Now there are only 5 winning numbers. We want to match exactly 3 of them. Out of the 5 possible winning numbers, we want to match 3 of them. This is the combination 5 winning numbers. Choose 3 of them. 2 of the first 5 numbers have to be incorrect though. How many combinations can those 2 incorrect numbers have? Well, there are, out of the 70 numbers that are drawn in the first 5, 5 of them are winners. 5 of them would be included in the 3 winning numbers to win this prize. 65 of the first 5 numbers are losers. In our first combination, we're choosing 3 out of the 5 winning numbers. And then for our last 2 numbers, we're choosing 2 out of the 65 losers. The probability of matching 3 of the first 5 numbers can be found by doing the multiplication of these 2 combinations. 5 choose 3 is 5 factorial over 3 factorial times 5 minus 3 factorial. And 65 choose 2, that combination, using the formula, is 65 factorial over 2 factorial times 65 minus 2 factorial. These combinations result in 10 and 2,080. They have a product of 20,800. So there is a significantly higher than any other numbers that we've looked at so far. There's a lot of different ways that you can match 3 of the first 5 numbers when order isn't important. There's actually 20,800 ways that can be done. So out of the 12 million ways, over 12 million ways those first 5 numbers can be drawn, 20,800 match 3. Match exactly 3 of the 5. 3 correct, 2 incorrect. The probability of matching 3 of the first 5 numbers is 20,800 out of 12,103,014. Multiplying that by the 1 in 25 probability of matching the megaball yields 1 in 14,546.89. This is your probability of matching 3 numbers with the megaball and winning $200. As a percent, this would be 0.006874%. Your percent chance of matching 3 numbers with the megaball and winning $200. At this point, the prizes are getting a lot smaller. Matching 3 numbers without the mega ball is only a $10 prize. To determine the probability of winning this, we'll determine the probability of matching 3 out of the first 5 numbers, something that we just computed. That is 20. We just figured out that was 20,800 out of the 12,103,014 ways that those first 5 numbers can be drawn. And we'll multiply that by the probability of not matching the mega ball. There are 25 possible values for the mega ball. 1 of them matches, 24 of them do not. So the probability of not matching the mega ball is 24 out of 25. To find this total probability, the probability of both of these things happening, matching 3 of the first 5 and not matching the mega ball, we'll multiply. And this multiplication reduces to 1 in 606, a little bit more than 1 in 606. That's your probability of matching 3 numbers without the mega ball and getting $10. As a percent, this is about just over 0.1%, 0.1650% is your chance of matching 3 numbers without the mega ball. Matching 2 numbers with the mega ball would also earn you $10. This probability is found by determining the probability of matching exactly 2 of the first 5 numbers and multiplying that by the 1 in 25 probability of matching the mega ball. Again, we'll have to determine how many ways out of the 12,103,014 ways those first 5 numbers can be drawn, how many ways result in exactly 2 of the first 5 numbers being matched? How many ways are there that you can match 2 out of 5 out of the 12.1 million possible ways? And that will be multiplied by, again, the 1 in 25 probability of matching the mega ball. When those first 5 numbers are drawn, we want to figure out how many combinations there are of drawing out of the 5 numbers, drawing exactly 2. Again, we're using a combination here. This combination would be read aloud. 5, choose 2. There are 5 winning numbers. We want to pick 2 of them. 3 of the numbers that we choose, 3 of the numbers that are picked to win this prize are incorrect. So we'll multiply 5 choose 2 by 65 choose 3. 65 choose 3 comes from there are 65, these last 3 numbers that are picked are not matching. 65 numbers of the 70 do not match. We want 3 of those 65 non-matching numbers. That can be found using this combination, 65 choose 3. Applying the combination formula to these 2 combinations yields 5 factorial over 2 factorial times 5 minus 2 factorial for 5 choose 2. And 65 choose 3 looks like this. Those simplify to 10 times 43,680. And has a product of 436,800. Understand that this means that out of the 12 million ways there are for those first 5 numbers to be drawn, 436,800 of those ways ends up matching 2 of the first 5 numbers. Again, order isn't important. Maybe you match the first 2 numbers and then the next 3 drawn are incorrect, or maybe the first 3 are not matched and the last 2 are. But any of the ways that match exactly 2 and do not match exactly 3, there are 436,800 ways that can happen. And again, that's out of the 12,103,014 possible ways those first 5 numbers can be drawn. When multiplying this by this is the probability of matching. This is the probability of matching 2 of the first 5 numbers. The probability of matching the mega ball is 1 in 25. Multiplying those probabilities give you the probability, the exact probability of matching 2 numbers with the mega ball, which is, rounded off to 2 decimal places, 1 in 692.71. As a percent, 0.144%. is your percent chance of matching two numbers with the mega ball and winning $10. The next highest prize comes from matching one number out of the first five and matching the mega ball. This wins $4. We'll again compute the probability. We will again multiply two probabilities. First, the probability of matching one, exactly one, of the first five numbers, matching one and not matching four, and multiply that by the probability of matching the mega ball. We will find that there's actually a lot of different ways, a lot of different combinations of matching exactly one number and not matching the other five out of the 12,103,014 ways that those first five numbers can be drawn, and we'll multiply that by the 1 in 25 probability of matching the mega ball. So, looking at the probability of matching one, exactly one of the first five numbers, well, matching that one number, there are five possible winning numbers. Out of those five possible winning numbers, we want to match one. The other four numbers, we do not want to match. Out of the first five numbers drawn, out of the 70 numbers that those come from, 5 of them are winners. We want to match one of them. 65 are losers. We want 2 of those 65 losers choose 4. This combination would be read 65 choose 4. We want, in this situation, 4 losing numbers to come from 65 possible. These combinations would look like this if I write them out and simplify to 5 for the number of combinations of matching 1 out of the winning 5, and 677,040 ways to choose 4 not matching numbers out of the 65 that don't match. This product is 3,385,200. Of the 12,103,014 ways those first five numbers can be drawn, 3,385,200 ways result in one number matching and 4 numbers not matching. This is the probability after those first 5 numbers are drawn that exactly one is matched, where order is not important. Multiplying that by the 1 in 25 probability of matching the mega ball yields 1 in 89.38. The probability of matching one number with the mega ball is 1 in 89.38. As a percent, this is 1.1190%. That's your percent chance of winning the $4 prize for matching one number with the mega ball. Finally, the probability of matching only the mega ball and winning $2 will come from determining the probability of matching none of the first 5 numbers, all of the first 5 numbers not matching, and multiply that by the probability of matching the mega ball. So, how many ways out of the 12 million ways those first 5 numbers can be drawn? How many of those ways result in no matching numbers? We'll multiply that by the 1 in 25 probability of matching the mega ball. Well, there are, out of those 70 numbers that are drawn in the first 5, 65 of those are losers. We want to pick 5 out of those 65 as a combination. That's 8,259,888. That's how many ways that after drawing 5 numbers, none of them match. Again, there are 12.1 million, just over 12.1 million ways those first 5 numbers can be drawn. The number of ways after they're drawn that none of them match is a total of 8,259,888. We'll multiply that by the 1 in 25 probability of matching the mega ball and get our total probability of matching only the mega ball, which is 1 in 36.63. Almost 1 in 37 is the probability of matching none of the first 5 numbers and matching the mega ball. As a percentage, this is a 2.7299% chance of hitting this $2 prize. And finally, on the screen now is a summary of the probabilities and percent chances to win all of the prizes in a Mega Millions drawing. In the description of this video, you'll see a link to the times in the video where the probabilities for each of these prizes are computed. If you have any questions, please ask in the comments below.